When you create the alignment for your cul-de-sac, the string content on the right hand side of the form now becomes available. Because we have an alignment, we're now in a position to be able to create the string. At the very top of the form we have some informative information about the start chainage and the end chainage, the center point, and if the offset has been specified, that offset value will be written. This information will come in handy when we come to look at the automatic design. We then have the template, and this is currently set to auto, so this is very similar to how the curve return module operated. The software will take the codes from the left hand side of the template on your road string and then automatically connect them to the codes on the right hand side of the template. Now if your template happens to be different from one side to the other, then it will only connect the codes which are similar. It's always important to note that there needs to be at least one code which matches, and that has to be generally the EB code. Underneath we can set the section spacing. So traditionally when we've created, for example, a grading string, we've varied this number. If we've created a road string, we may have put around 10. Now a section spacing every 1 meter for a cul-de-sac is a pretty reasonable value. Refer to the next lesson on vertical design where we discuss how to change this value after the cul-de-sac string has been created. Because we're using auto, we get the option to not have the batters being drawn at the edge of the template. So we can tell it to omit if we want to, but for the time being we're going to make sure they are drawn. Underneath we have automatic design, and this is how the software will actually go about designing the vertical design of this particular cul-de-sac. The hover graphics are going to be of assistance here, so whilst we're looking at these particular cells, the hover graphic will also provide you with assistance as to what exactly is going on. Calculate levels 2. This provides a chainage. This chainage is how far along your road string the software will calculate the levels of your cul-de-sac. The way it calculates the levels is that it takes the elevation of the centerline, takes the edge of bitumen elevation, which in this case is -3%, and then it will project that slope until it strikes the edge of the cul-de-sac. And it will continue to do that every 1 meter, which is our spacing, until it gets to chainage 364.739, which happens to be the center point chainage. So every 1 meter from the start, -3% will be projected until it strikes the edge of the cul-de-sac and will terminate at the center point. The calculate levels 2 on the bottom of the form will do the exact same thing, but coming around the back end of the cul-de-sac. So in this case it will continue to do the same thing all the way through and terminate the calculation at the center point. And then you'll see later on when we review the vertical design, the software will connect these two last points with either a reverse curve or a single vertical curve. The centerline endpoint is currently grayed out. This is because if we want to move the centerline endpoint, which is currently terminating right in the middle of the cul-de-sac, we have to use the omit pavement code option. If we decide that we want to move the center point forward or back, the software needs to be able to calculate levels all the way through the cul-de-sac, and it can only do this by omitting the pavement. So if you wanted to move the centerline endpoint, we would check the omit pavement code option, and by doing so the centerline endpoint cell becomes available for us to edit. We're going to uncheck that particular cell. Underneath that we can choose to have a slope to an offset center point. Now when we created the alignment geometry, we did not specify an offset center point. If we did specify an offset, the software would maintain the elevation of the centerline at that particular location and simply move the elevation across. If, however, you wanted to specify a slope of, say, -3% to the offset center point or a +3% to the offset center point, you could put that particular value in there. We're now going to click on Create Update String. What you'll see is that road 2 has been trimmed off, and then auto model has been updated to match up to the line work. Now, if for whatever reason you're not seeing the line work on screen, there are a couple of factors which could impact that. It could be that your image that is currently being displayed within the drawing environment, the draw order for that needs to go back, Also, you may find that you just need to do a simple regen in your CAD environment to refresh the screen. What we're going to do is click on Show VGE on Close and then close the form. We're now going to look at the vertical design that's being applied to our cul-de-sac.